All right, so factoring. Basically, we're rewriting the expression by taking out, first we're going to do common factors. So I look at 15x cubed minus 5x squared. Just look at the numbers, 15 and 5. What is a common factor of 15 and 5? 5. So when you're factoring, take out the number, take out the common number. Now, looking at x cubed and x squared. What can you take out between x cubed and x squared? You take out, there's more than you can take out than just an x. X squared. When you're doing radicals, when you're doing variables, take out the lowest exponent. Okay, so you have an x cubed, you have an x squared, you can take out the x squared. So on the outside, because when you factor, you're creating brackets, right? The whole point is to create brackets. So 5x squared is on the outside. To get what's left in the brackets, you divide by what you took out. Okay, so what's 15 divided by 5? 3. What is x cubed divided by x squared? What do you do with the exponents? You subtract them. So really you're doing that, which gives you just x, right? Minus, what's 5x squared divided by 5x squared? 1. How can you check to see if you did it right? Yeah, if you multiply it back in, you should get the original. So if I multiply 5x squared by 3x, I get 15x cubed, and 5x squared times negative 1 is 5x squared. Okay? That when you're factoring, you're just trying to make brackets, essentially. All right? Okay, next one. Look at the numbers first. What's the common factor of 8, 4, and 4? 4. You take out the largest common factor, I guess I should say. Because you could take out a 2, but that's not the largest. You always want to take out the largest you can. So we take out a 4. What about p cubed, p squared, and no p's? Can I take out any p's? No, it has to be in every single one. So I'm just taking out a 4. What am I left with in the brackets? 2p cubed minus 2p, minus p squared, sorry, not 2p, minus p squared minus what? 1. Just extend that. Okay? You always take out a common factor. That's the first thing you do. All right? When you're factoring, you look for a common factor. Okay. Okay. Next one. If you have two terms, okay, think of difference of squares. So we've already sort of seen this with the conjugates, all right? Difference of squares means if I have x minus a, x plus a, those are conjugates, right? We just wrote a test on it. If I multiply those together, what do I get? X squared minus a squared. Okay. When you're factoring, you're starting with this and you're going back to this. So you see two terms. All right, separated by a subtraction sign. I want to make two sets of brackets. What am I going to write in the first of each bracket? What's going to multiply to give me x squared? X. So we get x and x. And then what's going to be in the second bit? What? 9. What's the perfect square root of 81? It's 9. One has to be subtraction, one has to be addition. It doesn't matter the order you write them in. That's a difference of squares. Two terms separated minus sign. Essentially, you square root each term. So if I look at B here, I have two terms separated by subtraction sign. Ask yourself, can you square root 25? Can you square root a squared? Yeah, it would just be a. Can you square root 49? Yes. So what is the factored form of this? 5a minus 7 and 5a plus 7. The answer for difference of squares is always conjugates. Okay. What about C? Sorry? Except you have an addition sign, right? If you have an addition sign, it's not a difference of squares because the word difference means subtraction. Okay? So this one you can't do anything with. It's not possible. D. Can you square root 16? Can you square root t squared? Or square root 64? Do we have a subtraction sign? So now it's a difference of squares. So what is it? That's it. All right. That's your final answer. Well, actually here you can actually go further. So in this one, I'll talk about that in a bit, but you can actually take out a common factor from each of these, right? Yeah, you're on the right track. So I can take out a 4 from here. Common factor of t plus 2. I can take out a 4 from here, which is t minus 2. Does everybody see that? And then 4 times 4 is 16. So there is, you should always factor until you can't factor anymore, until you can't pull out a common factor. Now that's the long way. There's a shorter way to do this. If right at the beginning you look at it, and we'll talk about this on the next page, take out a common factor first. Okay? Common factor of 16 and 64 is 16. So then I'm left with t squared minus 4. And then this is a difference of squares, which gives you that. T plus 2, t minus 2. All right. I want to wait to do the next one. So all I want you to do here is number 2. A to E. Just number 2, A to E, please. That students remember from grade 10. You got a trinomial. Does anybody remember how to factor trinomials? So this is where you look for the numbers that multiply to the end and add to the middle. So what multiplies to 30 and adds to 11? 5 and 6. Okay? So then we write 2 brackets. So we're always trying to make brackets. whatever this is, whatever letter, A, X, B, whatever, if it's squared, you just put one of each, because essentially you would FOIL them to get that. And then at the back are the two numbers that multiply to 30 and add to 11, 6 and 5. Are they both positive? Positive 6 plus positive 5 is positive 11. So, remember this? This is what most people remember.